Hi everyone. As was just said, I'm Uri Yerushalmi. I'm the co-founder and chief AI officer at Fetcher. A few words about myself before we begin. I've been building software products that are backed by AI, machine learning, and data science for more than 3 decades now. My academic background is a PhD in computational neuroscience. That's why you'll see some biology references in today's presentation. And you'll also see some references to high frequency trading and algorithmic trading. And that's because before founding Fetcher, I was head of AI division in Wall Street algorithmic trading firm. Now, you are all from the AI community. And we all know the landscape of applications that are adding value based on generative AI.
And this landscape can be classified to two portions. Some of these applications are more based on textual and language generation, like ChatGPT and so. And some of these applications are more oriented toward imaging. We have at Fetcher have recognized an untapped potential with these models that relate to enhancing revenue for businesses by adding more profitability and growing the revenue in various businesses while adding to them more capabilities to be more and more autonomous. And by that, we are doing that by introducing into these businesses business agents that enable doing so. Now, from our experience in other industries, like in algorithmic trading, we have learned that it's essential to have a model that can predict the future market dynamics in order to enhance the revenue for businesses. And therefore, while most of us in the AI community have been focusing on building models that are generating either text or image, we have been in Fetcher, we have been focusing during the last 5 years on building large market models. Large market models are models that are anticipating the future market dynamics. Now, you may wonder about the applicability of generative AI to markets because it doesn't really match in first glance. Usually, generative AI when it comes to text is about generating tokens. When it comes to images, it relates to generating three-dimensional tensors. For example, in image, we have height, width, and color dimensions. In our case, we're talking about much higher dimensionality. Some of the dimensions in the outputted tensor of our large market models. Some of the dimensions relate to the product that we are talking about. Some of them relate to the competitors. Some of them relate to the type of customer. And eventually, we also have pixels in this outputted large market model. But the pixels are not visual. The pixels are pixels that relate to various probabilities. Probabilities, for example, for certain demand elasticity or for certain competitiveness of a certain company or for pricing of a certain company and so on. Now, when we started, we needed to choose where to apply these first business agents. And we were wondering what are the attributes of the market in which these business agents should start acting in. So we were looking for an industry that is complex enough so that once these business agents succeed in that industry, it would be clear that they can succeed almost anywhere. We were looking also for an industry that is outdated and it has a lot of volume and potential. Eventually, we have chosen the airline industry. The airline industry is very complex. Whoever here tried to book a flight that has two legs that are different one from the other, good luck with that. It's not very easy to do so because the airline industry is complex. It's very outdated. Whoever here worked in some airline knows that the systems there are decades old. It hasn't been disrupted for decades because of the same reasons, and there is a lot of volume there in that industry. Moreover, that industry is an industry that is an anchor to other travel-related industries. So today, we are working with various airlines that are, some of them are presented here, airlines that vary one from the other cost-wise, meaning some of them low cost, some of them not. It relates to the way they are working. Airlines that are in different continents, meaning geographically variant, and airlines that also different one from the other size-wise, meaning small and big. And today, we are already live for more than 3 years. We are managing a revenue of these airlines in order of billions of dollars. And we are steadily showing revenue uplift that is double-digit for these airlines, meaning it is very significant for them. Everything is based on the business agents that I would be presenting today. Not to mention the decrease in manual processes that is thanks to having more autonomous processes in the airlines. Now that I've presented what actually we are doing, let's try to understand the role of these business agents. So the business agents are introducing AI into the business, which is a player in some advanced markets. So if you are trying to look at it from a very high level, maybe we shouldn't look at the role of AI in the advanced market, because AI is one type of intelligence. So let's generally look at the role of intelligence in advanced markets. And if we are already talking about so high level, then advanced markets are one type of a complex system. So instead of talking about advanced markets, let's talk about complex systems, meaning the role of intelligence in complex systems. Now, I'm going now to try to think about the earliest player in a complex system that we can think of, and that would be some primordial molecule 4 billion years ago that started processing data from its environment and replicates itself. So whoever here didn't like biology lessons in high school, sorry about that, it will take only one slide. We're going to talk about biology. So that's our primordial molecule that understood what is the best way for it to replicate itself. But at some point, one of these molecules started taking more managerial role, a molecule that is very DNA-like, and it started guiding its environment, forming some coalition of molecules that got an advantage over their competitors. And they started replicating themselves in a more efficient way, forming a new entity, which is the cell. Now note that this phenomena is a phenomena that is going to repeat itself over the evolution, where some entity gets access to a more intelligent entity for guidance, forming a coalition that has advantage over its competitors. And that's also true not only for the primordial molecule, it's also true for the cell, because the cells started forming a new type of entity that is a little more intelligent, which is the neural cell, forming a coalition of cells that is actually a tissue, and it has advantage over its competitor. The first such like tissue was something in a jellyfish back then in the evolution. And these tissues also can be seen over evolution as tissues that started getting some central guidance, which is a brain or a central nervous system that creates a coalition of tissues that are actually an organism, like a human. And these humans also create coalitions, and these coalitions are businesses, just like the businesses and the companies we know. And these companies also can get access to a more advanced type of intelligence, which is the business agent. And we can also think of other layers of higher economies that would be taking such an advantage. Now, let's focus on this specific business that initially doesn't have any access to a business agent, and at some point it gets the access to the business agent. Once the business gets access to the business agent, it has capabilities that it didn't have before. Capabilities to make decisions that are much more optimal, or to unlock revenues that it wasn't capable to gain before, or to be much more proactive because it would know by having access to the large market model how would the competitors react to what it is going to do. Not to talk about low latency reactions to things that are happening in the market. Now, the problem that we initially have seen is that there is some missing link here between what we know and see in the market. You are all from the community, so you know what magnificent tools are out there. But we haven't seen the surge in business thanks to these tools. We know that there are tools that are reshaping industries, but at the same time, we haven't seen any business that got much more autonomous than it was before using these tools, or had a significant growth in its profitability or revenue. And we at Fetcher see our goal as the one that link the two. Now, the question is, what causes that missing link? And we believe that the missing link is because some capabilities that are lacking in large language models. And the problem with large language models is that they are trained on human-generated text. And that inherently causes them to have some attributes that project a ceiling to their capabilities. For example, because they are based on human-generated text, they will always be qualitative in some sense. But running a business is not only based on being qualitative. Businesses need to understand the market dynamics. They need to be quantitative because running a business is about numbers. Also, because of the way the language models are trained, they would always, in some sense, mimic humans. But running a business is not only about mimicking humans, it's about having decisions that are very quantitative, where the goal is to drive revenue and optimize the operations. While if you are capable to mimic humans, then your goal is more oriented towards reducing the human resources costs. And therefore, we introduced our large market models. The large market models are not trained only on human-generated text. They are trained on market data. And in a moment, I will discuss what do I mean by market data. But the market data is, by its nature, it's quantitative, so it enables the large market models to be quantitative. The market data is multidimensional, while the human language or human reasoning is limited in its dimensionality. And because of that, it enables the large market models to go beyond human reasoning. And these models are, in their essence, designed to drive revenue and optimize operations of a business. Now, let's try to understand what are the attributes that are required from such a business agent. Now, in one of the previous slides, I draw a comparison between business agents that in some sense are the brains of a business to a central nervous system of a human, which is the brains of a human. In both cases, we need, for example, some region of the brain or some model to process data from the environment. So in the brain, we have such a region. In both cases, we need some model to model the environment around us. So in the brain, we have the cerebellum. In our case, in the business agent, we have the large market model. The same goes to planning ahead. In the brain, in our prefrontal cortex, we have a region that simulates what's going to happen next, what would be the outcome of every action that I might do. In our case, as I will show in the business agent, we have also some simulation engine. So the same goes to outputting the data and, for example, for communicating with other humans. So we are using in these business agents large language models for the sake of communications with other humans. And there is also a language region in the human nervous system. And some word about instincts. Instincts are very important for human survival. Actually, all of the attributes that I showed are attributes that over millions of years of evolution have been created in order to allow the humans to survive. And that's something that we need also from these business agents. And when it comes to acting quickly and responding quickly to stimulus from the environment, the business agents also have some real-time engines, just like humans have the brainstem. Now, note that once we have all of these attributes, it allows the business agents, just like human brains, to make decisions in a wide range of possibilities, from very quick instinctual decisions that are very granular and real-time, two very strategic, long-term planning ones that require more time to think and to simulate and go over all consequences of the decision that would be made. Now, in the next slides, I'm going to go over some type of decisions and how are they built and trained in our business agents. So initially, we need to gather data from the environment. Once the data is gathered from the environment, in businesses, we are talking about 2 or 3 years of data. In some cases, it can be more. In some cases, it can be less. The data is used to train the large market model. And once the large market model is trained, it can output these multidimensional outputs about certain situations that hypothetically can happen in the future. These outputs are representing possible scenarios in the market dynamics. And once it is capable of doing so, there is a simulation engine that simulates what would happen if I will take a certain action, going deeply into the future. The simulation engine checks various policies or actions that the business might do, scanning the space of all possible actions that the business would do, and it chooses the best policy of action to be made. Once the policy has been chosen, it is pushed through the real-time engines of the business to be taken. Now, I'll dive maybe deeper into each one of these steps. First, let's talk about data consolidation. When we are feeding our business with data, there are actually two types of data or two types of origin of the data that are relevant here. We are always splitting it into internal data that is proprietary for the business and data that is public domain that we purchase and consolidated into the large market model. Internal data relates to prices, for example, of the products that the business sells, orders, shopping data, transactions, and so on. On top of that, we are gathering data that is more external, information about the competitors of the business, about the weather, news, events that are very influencing in some cases, regulations, information from capital markets, and so on. All of that data is consolidated into one central place, and that data is used to feed the large market model. Now, I will not dive into the neural structure of the large market model, but it is a big neural network based on deep learning techniques. What's interesting here is the output of that large market model, which, as I said before, it is a multi-dimensional output. Now, a big portion of you are probably data scientists, so when we are talking about high-dimensional data, we as humans like to lower the dimensionality and look only at maybe 2 or 3 dimensions. So in that case, we have prepared some examples of very specific product, very specific time, very specific customer. And we are here showing only a 3-dimensional data where the x-axis is the potential price of the product. The y-axis is the potential price of one of the competitors. And the colors here represent the expected demand in a quantitative form. Note that these colors should make sense because as the price of the product goes up, we get more into the blue areas where the demand is low, and as the price of the competitor goes up, we get into the red areas where the demand is high. Now, once we slice that multidimensional output of the large market model in different cases, we can compare some interesting cases. For example, these two cases. Note the difference between these two cases in a human visual form. The difference is that in one case, the competitor has a high impact. In the other case, the competitor has low impact. The low impact case is a case where as we move vertically, nothing really changes when it comes to the demand of our product, meaning when the competitor changes prices, it doesn't happen. Now note that these outputs are not outputs that were generated by some data scientist or by some business analyst. These outputs are outputs that are generated by the large market model, quantitatively describing from the point of view of the large market model, it is just showing us the distribution of demand historically for these cases. Other interesting cases relate to some shift of some equilibrium line between the price point of our product compared to the competitor demand. So you might see that shift of this green line in the middle, that has a meaning. That shift shows the change in the perceived value of these two products. We can also see some cases that are not well documented in economy cases or notations. Here we have something new that is more relating the low contrast versus high contrast competition. We see that in certain markets, these markets are in high contrast, meaning every cent matters where you are close to that equilibrium line. And these differences are differences that allow the large market model to be the backbone of simulations that would eventually make a lot of revenue for the business. So we have seen the output of the large market model. Let's talk about the simulations. Now, these simulations are very computational intensive because we need to go for every decision here is actually a decision that has a lot of dimensions in which we need to simulate. And for every decision, the consequences would be outcome for the business throughout the future in many steps. So for every such possible policy, we need to make a simulation, but that's not enough to do it for one policy. We need to do it for many policies, scanning the space of possible policies and eventually understanding how would that space look like. And what's interesting is that thanks to the accuracy of the market models, we can see things that are not easy to be seen even when you are looking at the actual market. For example, here we see autocorrelation plots of prices of certain products. These autocorrelation plots are plots that are not generated from the actual data in the market, that are generated from the simulations. And these plots, in our case, the blue line represents the customer for which the business agent works, meaning our customer, and the other lines are the customer's competitors. And for example, one of the competitors has very high cross-correlation values. This has a meaning in the business world. It means that this competitor has high tendency to match prices to our customer. Now, that's something that the business analyst knows, because here we peek into the brain of the business agent. But the human analysts in the company don't really know it. So here, that's an outcome that actually shows that the business agent is smarter than the human analysts in the company. The orange case is a more interesting case where one of the competitors is very lagging behind. The fact that it's lagging behind relates to the fact that the time lag of the cross-correlation values on the negative side is much higher than the positive side. And again, these are things that the average human analyst in the business that is human will not know about this tendency in the data. Okay, so we have seen the outcomes of simulations. Now, once we scan the space of possible policies, we can think of a reward map or reward landscape. Now, as I said before, every policy is a very high dimensional one. Here we reduce the dimensionality of the policy to 2, just for the sake of visuality. And we can see that one of the policies, the one that is here colored in yellow, policy A, is the optimal one. So that's the policy that would be chosen and applied for the business. And when we need to apply the policy for the business, it means that the policy is going to be acting in real time, something that is very difficult for humans to do. The decision can be taken every millisecond and pushed immediately to the right channels, so the business would be proactive and responsive in very manner. All of the decisions are tracked and logged for compliance reasons later. Now, what we have seen until now are capabilities of a business agent, which is very smart, which is very granular, which is very fast, meaning the AI portions of the business agents are in very high quality. But we know that it's not enough. How do we know that? Because we have experience in capital markets when it comes to trading firms. We know that for such a business agent to act well, it needs also be seamlessly integrating into the business. So for that, we are showing here a use case of how these business agents today are making automatic decision in Virgin Atlantic. So if one of you has flied in Virgin Atlantic, most probably that you have flied and bought a ticket that was priced automatically by business agents or fetcher on Virgin Atlantic case. Now, when it comes to seamlessly integrate into a business, actually when we are integrating to the existing brain of Virgin Atlantic in that case, and the existing brain is made of humans that are the employees of the business. And they need to understand and count and have confidence in our business agents. And only once they have this confidence, they would let the business agent work automatically. And a major part of having confidence in the business agent is understanding the reasoning behind its decisions. That's why we have developed these business agents having explainability at their core, meaning every decision is logged, including its explainability features, so that the pricing analyst in this case can go over all features that influence the decision and dive in a hierarchical manner deeper and deeper, understanding all of the factors that in this case push the price upwards by $26. Now, just explaining decisions is not enough. And we have learned that the best tool to enable good communication between the humans in the organization and the business agent is actually a large language model, because large language models actually both live on both sides. From one side, there are computer science models, but from the other side, there are language models that can communicate well with humans. So it placed our business agents in an interesting point where they contain both very interesting and powerful models. From one side, they are using large market models to model the future dynamics in the market. And from the other side, they are using large language models in order to communicate well with the existing infrastructure of businesses. So here, what we are seeing is a chat between a pricing analyst in Virgin Atlantic and the business agent, where the business agent is not just chatting with the business analyst. The business agent can be used to explain various decisions that it has made before. The business agent acts like a business intelligence to understand what's going on in the market. The answers of the business agents are not necessarily only textual. It generates reports on the fly in order to explain what's going on and what's going to happen next. The business, thanks to the capabilities relating to simulations that I've shown before, the business agent can be asked, what would be happen if I will not do your recommendation and do some other thing? What would be the consequences of such an action? The business agent can answer these types of questions, and it can also take actions, meaning I can, as a human, can tell it what to do, even if it is not according to its recommendation, and it will do it. Now, as for the products that we have in Virgin Atlantic, we had 3 types of business agents there. Starting with the general pricing engine. Second product is the generative inventory engine and generative network engine. These 3 agents are working together, where the pricing engine is a pricing engine that is more related to having real-time dynamic pricing, taking care of all of the decisions that relate to being dynamic and being continuous. The inventory agent is more related to resource allocation, and the network one relates to making decisions that are much more long-term, relating to how to structure the network of the airline. Now, once these agents are in place, there is a shift in the landscape of the market dynamics. What you see here is on the left, you see the landscape before the agent is applied, and what on the right is after the agent is applied. Every line here represents the pricing dynamics of a certain product. What we see on the right is that the dynamics is much more similar to dynamics in NASDAQ or capital markets, where the prices changes much more frequently, because every time something in the market changes, there is an immediate response. The changes are more gradual, but over time they are much more apparent. The changes are less, the change land other, because something, which is the business agent in the background, takes care of every product separately, while humans would tend to group products together. And the changes are not only more responsive, but they are much more proactive, because the business agent, part of its decision relates to anticipating how would competitors react to its actions. Now, part of having trust or confidence in the system is actually proving to the humans in the organization that this is working. It is making money for the business. And the best way to prove that is to have a scientific A/B testing. So the A/B testing capabilities are also inherently built into these business agents. And here we can see the results. As any A/B testing, we have a control group. The control group here, represented by this orange line, represents the expected revenue for our product based on some control products. So that's the expected revenue, and there is the actual revenue here is in blue. Now, in some days you will see that the blue line is below the orange line. In some days it's above the orange line. When it's below the orange line, it means that there was some lost revenue, but usually it's way above the orange line, meaning usually the revenue that the business agent gained was much, much higher. And once you accumulate that over time, we can see that we steadily generate double-digit percentage of revenue over the control group. Now, we have seen that these business agents allow having decisions autonomously, and not only having them across the business operations, but they optimize operations in real time while driving much better, smarter, and faster business outcomes. And we have also seen that these results are based on various capabilities. First, we need to have trust in the system. The trust is built based on LLM capabilities communicating to the humans in the business. It is based on explainability and integrated A/B testing. It is also important to mention that the seamless integration was a key part here. These systems are piggybacking on existing channels. They do not require changing a lot of pipelines in the business. So the implementation is zero risk, and only once the the business sees that they are successful, it allows to sunset all systems. And on top of everything, they are based on very granular and very accurate AI models. And last thing, it is important to say that everything that we saw today is very agnostic. The capabilities of applying what we saw are capabilities on wide range of businesses, starting from legacy organizations, pushing the legacy organizations towards being more modern. And we also have very modern organizations where we are giving them significant advantage over their competitors. Thank you, everyone.